Okay, good afternoon, my students. It's me again, your math technique teacher. Today, I will be discussing to you the third lesson in Module 2 or in arithmetic sequence, which is the sum of the terms of an arithmetic sequence, or also known as the arithmetic series. So what is the difference between an arithmetic sequence and an arithmetic series? Example, if we have the sequence 2 as the first term and we have the common difference of 3, the second term would be 2 plus 3, 5, plus 3, 8, plus 3, 11, plus 3, 14, and so on. So this is an example of an arithmetic sequence with a common difference of 3. It increases by 3. So what is its equivalent in arithmetic series? So all you need to do is to make a big S, which stands for the sum, is equal to 2 plus 5 plus 8 plus 11 plus 14 plus and so on. So that's the difference between an arithmetic series and an arithmetic sequence. If you are going to add the terms of the sequence, it will be called a series. Okay, for our first example, the sum of the first 8 terms of this arithmetic sequence, 5, 9, 13, 17, and so on. So if you will be asked to get the sum of the first 8 terms, in arithmetic series, it would be S is equal to 5 plus 9 plus 13 plus 17 plus and so on. So if you are going to write this in arithmetic series form, S is equal to 5 plus 9 plus 13 plus 17 plus and so on. So how do we solve this problem? Obviously, it is easy for you to get the sum of these 8 terms manually. But do we have a formula to follow? Yes, the formula that we are going to follow is S stands for the sum equals n over 2 times this result, which is 2a sub 1 plus the difference of n and 1 times the common difference. Or in the Philippines, we also read this as the quantity of n minus 1 times the common difference. So, as you can see, this part of the formula is familiar to you. This is the nth term of an arithmetic sequence. Okay, in the next examples, it will be more clearer if where this formula came from. So if we are going to follow this formula, where you need to do first is to identify the n or the number of terms, and then the first term, the number of terms, and the common difference. So the n here in this problem is we have the 8 terms. So we have n is equal to 8. The a sub 1, which is also a requirement, a sub 1 is 5. And the common difference. In this, it increases by 4. So 5 plus 4, 9, plus 4, 13, or 9 minus 5, 4. 13 minus 9, 4. So your common difference is 4. So by substitution, the sum is equal to n, the number of terms, 8, over 2, multiplied by 2 times the a sub 1 is 5, plus you have your n, 8, minus 1, that's the constant, times the common difference of 4, then close brace, equals 8 divided by 2 is 4, 2 times 5 is 10, plus this is 8 minus 1. So 8 minus 1 is 7. 7 times 4 is 28 plus 2 times 5 is 10. So these braces are used because there are parentheses inside. If we remove the parentheses, these braces will be converted to parentheses. So our next step is 4 times the sum of these two is equal to 4 times 10 plus 28 is 38. 4 times 38, 4 times 30 is 120. 4 times 8 is 32. So 4 times 38 is 152. So the sum of the first 8 terms, so there is sub n here. It means the number of terms, s sub n, s sub 8, s sub 8. The sum of the first 8 terms is 152. So we have solved the problem using the formula. What if we do the manual computation? So we manually get the sum of the first 8 terms. Okay, let us consider this as our checking. Okay, let's check if our answer is correct. What are the first 8 terms in this? So this is 4 term plus 4, 21, plus 4, 25, plus 4, 29, 1, 2, 3, 4, 5, 6, 7, and then the last one is plus 4, 33. So 5 plus 9, 14, plus 13, 27, plus 17, 54, plus 21, 65, plus 25, 90, plus 29, 119, plus 13, 152. So our answer is correct. We have checked it manually. So it's easy for you to check because there are only 8 terms in this series. For our example number 2, find the sum of the first 19 terms of the arithmetic sequence -2, -5, -8, -11, and so on. So this time, the sequence are negative integers. So how do we get the sum of these 19 terms? So basically, if we are going to add negative integers, the result is also negative integer. So we are looking for a negative answer. So the same thing, we are going to follow the same formula. S sub n equals n over 2 times 2a sub 1 plus the difference of n minus 1 times the common difference. So the sum of the first 19 terms, s sub 19 equals 19 over 2 multiplied by our a sub 1 is negative 2. 2 times negative 2 plus our n is 19 minus 1, 18 times the common difference. So the common difference is the number that we add to negative 2 to become negative 5, or in reverse, the number that we subtract from negative 5 to become negative 2. So negative 5 minus negative 2. So to get the common difference, the same procedure, negative 5 minus negative 2. Subtract the second term to subtract the second term by negative 2. Negative 5 minus negative 2, or the first term. Negative 5 minus negative 2, it will be negative 5 plus 2, because we have here a double negative, plus 2. So negative 5 plus 2 is negative 3. So our common difference is negative 3 times negative 3. Next step, 19 halves. Negative 2 times negative 2 is negative 4. 18 times negative 3 is negative 54. So negative 54 plus 2 times negative 2, negative 4. Then multiplied by, for the next step, 19 divided by 2 will give you a decimal number. So let's just copy 19 over 2. Then negative 4 plus negative 54 is negative 58, because negative plus negative is also a negative number, times negative 58. So from here, you may have two ways to solve this. You can multiply negative 58 by 19, and then the result will be divided by 2. Or you may have the cancellation. Why we can have the cancellation? This is denominator and this is considered a numerator, because every whole number has an invisible denominator 1. So even if it is negative. So we can do cancellation by 2. 2 divided by 2 is 1. Negative 58 divided by 2 is negative 29. So what is left? 19 divided by 1 is 19. 19 times negative 29 is equal to negative 551. You may also check your work by having all the 19 terms in this sequence. So extend negative 2, negative 5, negative 8, negative 11, negative 14, plus negative 3, negative 17. So until all the 19 numbers or 19 terms are there, and then you use your calculator, add it manually one by one, and you will see that the answer is the same, negative 551. Okay? Okay, before we continue to the example number 3, let me share to you first a short story about Carl Friedrich Gauss, the person who was able to get the sum of these first 100 counting numbers in just seconds when he was around 6 or 7 years old. So an elementary teacher, his elementary teacher has given this series to him to keep him busy, because Gauss find it boring those lessons those time, because Gauss is very much advanced compared to his classmates. So within seconds, without using any paper or pen, obviously there's no calculator during that time, without using anything, purely mental computation, he was able to get the sum of numbers of the first 100 counting numbers in just seconds. So can you beat that? Example, 1 plus 2, 3, plus 3, 6, plus 4, 10, plus 5, 15. So until 100. So Gauss did that in just seconds. So how he did it? Did he add those numbers manually, or he was able to have a solution or a formula? So Gauss solved this by observation and by analyzing that the sum of the first and the last number is 101. 1 plus 100 is 101. The second to the last and the second number and the second to the last number also has a sum of 101. So it's like pairing. Gauss paired the first and the last, the second number and the second to the last, the third number and the third to the last will also give you 101. So Gauss think that this series has 100 numbers and there are 50 pairs. So it would be 101 times 50. That's the sum of the first 100 counting numbers. So 101 times 50, 100 times 50, 5,000. 1 times 50, 50. So the sum is 50, 50 or 5,050. So it's not easy to forget the sum of the first 100 counting numbers, because it is simple as 50, 50. So always remember that the sum of the first 100 counting numbers is 50, 50.